ya casi. Por favor, recuerden apagar los celulares por Vamos a volver al inglés. The next talk is in charge of Marco Rebolledo from Merck, entitled Sustainability and Green Alternative Portfolio. Marco Rebolledo is in the past worked at the University of Chile as a lab manager, where he implemented a system to address the handling and classification of chemical residues at the Faculty of Science. He organized the chemical warehouse and optimized the solvent recovery procedure in a centralized facility. Additionally, he worked on synthesizing and testing various compounds with potential pharmacological applications, leading to more than 10 international publications. In 2011, he began working at Merck as a sales representative, then transitioned to Brand, Corning, Hitachi, DWK, Eppendorf, Labconco, among other brands. As a product manager, where he handled a wide range of products, then he became a supervisor for a team of specialists in our country, and from then he served as a product specialist for the workflow of chemistry and organic synthesis, nanomaterials, photochemistry, and isotopes. Currently, he is in charge of these matters for Chile, Peru, and Argentina. Please, Mr. Rebolledo, everything is ready for this.
Well, thank you all for the invitation. First of all, I would like to bring up your attention to mark that the life science business Merck Darmstadt, Germany, operates as Medipol Sigma in the United States and Canada. But right here in Chile and the rest of the world, well, we are known as Merck. Okay. Gracias. The foundation of Merck dates back to 1668, so 350 years ago. So all begins in a pharmacy called the Angel Pharmacy. It's kind of weird, but that was Freddie Merck that founded the enterprise that is known today. We will review about what we call the chemical workflow. As you can see, there is a bunch of products that we offer, but we are now going to concentrate about the green chemistry solutions that we offer within the workflow. So, first of all, we'll start with the bioreactive research that is part of every one of you done or do in the first early stages of the planning. And in this early stage, you need to identify what are the products you are going to produce, what you designed, right? So it's for vital importance to optimize this process that most of the time is a manual process that takes ages to gather all the information to get a valid candidate that you want to achieve, right? So today we're going to present some tools that we offer. These are artificial intelligence tool based. First of all, we'd like to present the Edison. Edison is a real drug candidate screening software that integrates artificial intelligence, machine learning, and it's a computer-aided drug design method to serve as a highly comprehensive tool to achieve what you need to look up in terms of the proteins of the products you need to create. One of the best things I believe that this tool provides you is from it elaborates what is the chemical spaces and facilitates physical, chemical, and machine learning analysis, so you can evaluate how it's going to be the toxicity of the product that is going to offer you as an alternative. So another tool we have is called Cynthia. Cynthia is another web-based tool. It's a synthesis software that allows you to design and plan routes of target molecules based on bench-validated methods. This is important. It enables the combination of search parameters. You can search how much steps do you want to apply. Also, if you want to use or not some protecting groups, that's for very important step. And also, you can use or not your own inventory. So you can, if you don't have it, you can purchase from the web page, of course, and you can identify which are the important topics that you would like to change or to emphasize when you're trying to figure out how to solve your synthesis process. When you have your product already, you can buy it, of course, from the web page. But once you already have your target molecule, also you have your family or your compound or your scaffold of products that you want to synthesize, obviously you want to go to the laboratory and start working on it. And also in this stage we have some alternatives. The first one is what we call catalysis. Catalysis is a kit. It's a kit you can buy from different parts. The main part of it, I will mark this block over here. That is an arrangement of 24 vessels that have the ability to harness a kit that you can buy separately, and you can do or carry on all this reaction in one single spot. So in this small device, you can run 24 reactions at the same time using the same condition and evaluate how it's going to carry on the reaction with the already pre-weighted substrate on it. Also, you will be having the steering bars on it, so the only thing you need to add is your compound and of course the other solvents that are already available as a kit. You can see the improvement in terms of costs when you make this screening, and then after you can run up as usual with utility and determine what is the best condition to your reaction in particular. Also, it's good to mention that if you don't have a glove box that is kind of expensive, you can use this small device and an existing fume hood to connect to your nitrogen or argon source in order to provide a clean and environmental, how do you say, without any oxygen? Inert gases system. So, thank you. So also, if you don't want to use a heating plate, you can also take the same block and place it on these devices that we offer to run a photocatalysis reaction. You can choose from 3 different wavelengths in order to take your reaction into account. Here you can see the kit that you can change, but the other components are all, of course, reusable. In terms of solvents, solvents possess many useful properties, and unfortunately some of them are very toxic. As Dr. Warner showed us today, I was trying to prepare something to explain how toxic are they, but everybody knows that about it. So when we are talking about the new solvents or green solvents industry, the Merck company are trying to focus on these 6 principles in terms of the 12 of green chemistry principles. So the products are renewable feedstock and solvents are safer than the regular solvents, are designed to be an energy efficiency and prevent the waste because they are biodegradable. Most of the time we're trying to change for the natural common solvents. They are teratogenic, right, or carcinogenic. just like NMP and DMF. And so one of the top ones everybody talks about is the styrene. Styrene is a cellulosic-based compound. The good news is completely biodegradable. In 30 days is nothing left of, and it has a low toxicity, and it allows you to carry on the regular reaction of NMF or DMF without sacrificing any yield results. Unfortunately, it's not perfect, but because it's a kind of a very high viscosity, so they came up with the idea to use some blends, as we call them. And here you can see blends with another green solvents, very common ones, and they reduce drastically the viscosity to make something very manageable and useful. In terms of yields, you can find it's also very good. I'm going to show you a little later. But we have around 30 different solvents that you can use in the green spectrum. You can see here 3 main categories. The yellow one is the regular solvents that everybody used, but in this time are bio-based. So the line of production of them is biocompatible, but at least they are the same product that you are used to use. In the middle gap here, we have the bio-based solvents, but also they are 100% produced. I mean, they are not bio-based, they are not regular products, but still are aligned with the 6 principles of green chemistry. And the last ones are not bio-based, but still are very good alternatives in terms of safety and biodisponibility and biodegradability. So here we can see a resume in the first, whoops, sorry. You can see here petroleum-based solvents that you are very familiar with, and the green alternative that they're offering. As I mentioned earlier, we have around 30 another ones, but this is the main ones. And the earnings in terms of CO2 emissions to take into account, and the properties of them. Here you can see some applications regarding some carbon-carbon coupling. That is very difficult to do, to carry on, but you can see how they behave in terms of yield. So you also not going to expect something that's going wrong in terms of the yields because you are using a green alternative one. Also you can see how it behaves with BMF, for example, still having very good yields and also saving some time. So in terms of efficiency, it's also a gain. So in summary, green solvents are here. So they are safer alternatives to you, and you can use them to reduce the risk of handling regular solvents in the laboratory. Regarding the last part, we have some products to offer to you. We have the purification, separation, and concentration techniques, and also include some products that may be interesting that you see that we have. We offer this condenser that doesn't use any water at all. They are some kind of aluminum construction system that doesn't need any water. So 98% of the common solvent you can run a reflux reaction without worrying about wasting any water at all. And also many people use this hot plates, but are still using some oil baths that are kind of messy and also produce waste every time you use them, or if you take out your flask, it's going to be full with that oil. So you can avoid all that using thermoblocks that are made of aluminum with some polytetrafluoroethylene coating, and it helps you to harness your reaction in a safety way. Also, we have a lot of rotary evaporators and also different tools that allows you to do this in a best and friendly way. Also, in terms of vacuum, if you want to feed a slate tube or your rotary evaporation system, or recover your solvents at most of the time at high boiling points, you need to reduce the pressure, right? So we offer these special pumps to reduce the pressure very efficiently, with high efficiency, using these coils, for example, that are made of PEEK, the same material that HPLC knobs are constructed, and you can produce vacuum similar to a regular oil pump system that are completely incompatible with solvents or corrosive solvents or acid, organics, or mineral acid. So, please do not use the common water pumps that runs with regular tap water, which is wasting all the senses, you can imagine. So, the last but not least, we have the importance of trying to look at it when you're trying to accomplish with something very large in terms of quantity. And if you are going to produce a large quantity of solvents, you always can run to a better or larger vessel that are available. There is no increase in the cost, and you will help to reduce the waste in not only in glass but also in the caps, and not pay for the final destruction of them. So, as you told us later, those tools are very important tool that we offer freely. You can use them to quantify based on the 12 doses, in the 12 principles, how sustainable is your process. So if you already are carrying out some of those processes and you need to change some solvents, for instance, methanol to ethanol, for example, you're going to be a different score. So easily you're going to figure out how are you going to improve your system in terms of sustainability. So that's it. I would like to thank you again. Here is my email. So if you have any question, I will be happy to answer you while in the poster session or in the cocktail, so I can practice my Spanish too.
So I invite you to the poster sessions. I think we can return at 4 because we are out of, no, it's not out of time. We are please go. We can go to the poster session now. Then we return at 4 o'clock in order to